What's up? What's up? It's your man Jimmy Chan. All right, so let's talk about quadratic functions as you would know it, quadratic equations. So quadratic functions in standard form would be y is equal to ax squared plus bx plus c, or f of x is equal to ax squared plus bx plus c. Now, in terms of concavity-wise, the a typically tells you which way it curves. So if the a was negative, then we have a frowny face, a sad face, just like negative and would do, right? And if n is positive, then we have a smiley face. Now, the other big difference is that with a smiley face, the lowest point would be called the minimum, while a frowny face, the maximum point is, or the highest point would be called the maximum. All right, which those two would also be considered the vertex. So no matter what form you're given in a quadratic function, we need these two pieces of information, the axis of symmetry and the vertex. With standard form, one way to do it is to actually use formulas to figure out what the axis of symmetry is and what the vertex is. All right, so let's go ahead and show you what that way shows me. All right, so here I'm given a quadratic function. I know that my a is equal to 2, my b is equal to 4, and my c is equal to -8. So the first thing I have to do is find the axis of symmetry. So before I even talk about that, however, let's talk about the value of a right here, right? The value of a here is 2, a positive 2. So that means I'm going to have a smiley face. Okay, so it's going to smile like this. All right, so what I have to find is I have to find the vertex, and not just that, also the axis of symmetry. Okay, so this pink line right here that is dotted is my so-called axis of symmetry. And that purple dot right there is called my vertex, and which I would know as the minimum. Okay, so to find the vertex, I gotta first find the axis of symmetry. So axis of symmetry has a formula which is x is equal to -b over 2a. So it'd be -4 over 2 times a, which is also 2. So that's going to give me a -1. In fact, I should put it this way. This tells me that x is equal to -1. So notice that my axis of symmetry, right? My axis of symmetry says that x equals -1, which tells me that my vertex already has an x value of -1. So what I want to find is my y value here. Okay, so in order to find that y value, what I would have to do is find the f of that -1, because -1 is my x value. So let's go ahead and plug that in. So I got 2 times -1 squared plus 4 times -1 minus 8. Okay, so I have -1 squared, which is +1 times 2 is going to give me 2. I have -1 times +4, which is going to give me a -4. And then I got -8, so that's going to give me, or that's going to tell me that f of -1 is going to be was that -10? Is that right? 2 minus 4 will be -2, minus 8 will be -10. So my y value here is -10. So my so-called vertex is -1, -10. Okay, so that's one way of doing it. All right, I'll show you a different way in just a couple minutes. All right, so the other form that we're going to introduce you to is called the vertex form. If you notice, the form is very different. It's a times x minus h squared plus k. Now notice that this is a minus h and this is a plus k, but the vertex is still h comma k. All right, so in other words, the h is going to be the opposite sign. Now, notice the concavity is still exactly the same. Negative and, still frowning. Positive and, still smiling. Okay? And then we'll find the axis of symmetry. So again, standard form, we found the axis of symmetry first, then find the vertex, where in a vertex form, we'll find the vertex first. Interesting, vertex form, vertex first, and then we'll find the axis of symmetry. So here is an example. So when we look at this, let's go ahead and compare it to the original equation here. So what I have is f of x is equal to 2 times x minus a negative 5, right? Because in order to get plus 5, I got a minus a negative. And then this is supposed to be a plus. That means I got a negative 7. So that means my vertex must be negative 5, negative 7 here. All right? With that being said, that means my axis of symmetry is going to be just x equals that negative 5. All right? So that's how I would do it if I was given vertex form. So you're like, well, if I can just have everything in vertex form, this would be cake. It would be so easy. You're right. But life doesn't work that way. So now I was mentioning a second method, right? So here is what we were talking about. So here we could convert standard form to vertex form by using completing the squares. The downside of completing a square is that a has to equal to 1. So here we go. Let's take a look. So here's an example. So for us to do this, what we need to do, because when we did completing the squares, it's always about kicking someone out of the house and then finding a new seed, right? So we found that 5 did something bad, so we're gonna move him into the doghouse, because we're not gonna kick him out of the house. We're just gonna put him in the doghouse. All right. But again, doing completing a square, a has to equal to 1. So this is what I have left, but they're in the doghouse, so they don't know what's going on. So I got to make sure that this a is going to be 1. So in order to do that, I'm going to factor out a 3. So I'm going to have left x squared minus 2x. And 5 has no idea what the heck is going on. All right? So with that being said, apparently they're being sneaky and looking for a new c anyways. Which my b is negative 2. So that is going to be a negative 1 squared, which is equal to 1. So I got to add 1 to this. Now, here is where the issue. I didn't really just add 1. I actually added 3 because I have the 3 times 1, right? This c is about in here. But on the outside, I actually added 3, okay? So, typically what we would do with completing a square is that if we add 3 on the right side, we would add 3 to the left side, right? So, the problem is that the left side has a y. It's not a 0 like before. It has a y. So, I got to bring the 3 back over. How do I bring the 3 back over? I got to subtract 3 on both sides so that this would go away. Okay? So that's what I would do. All right. So we have f of x is going to equal to 3 times, this is factorable to be perfect. And that's going to be x minus 1. And I hope that you know where that negative 1 came from. And then whatever the result of this is, which is a plus 2. Okay, so notice that I just went from standard form to vertex form. Okay, so again, standard form to vertex form. All right, so with that being said, I know what my vertex is. My vertex is going to be 1, 2. That means my axis of symmetry must be x equals 1. Okie doke. So just like that, I can get it into the vertex form, and then I can just get everything that I need from there. Okie doke. All right, so let's take a look. What else is in store? All right, so intercepts, right? So find intercepts. What I know is that the only two intercepts I know, the y-intercept. What do I know about y-intercept? Is that x is equal to 0. And then the other intercept we know is x-intercept. What do we know about x-intercept? Yes, the y is equal to 0. Okay, so when we put the y equals 0, that means we're going to put this y value equal to 0. So we're going to have left this quadratic equation. So that means I have to factor that non-zero side. Oh no, not factoring. Oh no. The good news is that majority of the time, we can either factor, we can use the quadratic formula, or we can use completing the square. Most of you guys are going to say, most of you guys are not going to say, let's go completing the squares. Most of you guys are going to say, let's use the quadratic formula, which is right here. Now, one of the things I always teach is that in the quadratic formula, once you fill it in, that what we want to do is make sure that we only type in the radicand into the calculator so that we know what that radicand is, and then we can determine from there. So with that being said, this so-called radicand has a special name. And so b squared minus 4ac has a special name called the discriminant, right? So now, if you think about this, this is inside a square root, right? So if it's inside the square root, if it was negative number, so if the b squared minus 4ac, or the radicand, in this case, the discriminant, is a negative number, well, what happens when I take a square root of negative numbers? Correct. I get imaginary numbers. Imaginary was cute when you were 5, and now you get, get put in a straitjacket and pharmaceuticals to get you straight, right? So, which means that we would have no x-intercepts. However, if the discriminant was 0, well, this would be 0, so it would be square root of 0 is still 0. Well, what is negative b plus or minus 0? Still just negative b divided by 2a. So that means there's only going to be one x-intercept. And however, if this is positive, then the plus and minus is still going to be there. So that means we're going to have 2 real intercepts or roots. Okay, so here is a table of what those discriminants we just talked about. All right, so the question is, how do we go about graphing these quadratic functions, right? Concavity we talked about, vertex and axis of symmetry depending on what we're given, right? Or axis of symmetry and vertex. We're going to plot those. Now, this is one way to do it, or we can always convert the standard form to vertex form and then just plot those. And then we got to find our intercepts and then use symmetry to plot the other points, and then we can graph. All right? Well, great. Here's an example. All right? So, number 1, concavity. All right? So, A is negative. So that means we have a frowny face. Okay? We have a frowny face. We know that. Now, let's go ahead and convert this to vertex form, okay? So first thing is that we're going to take this. We're going to move negative 9 into the doghouse, right? And then we're going to say f of x and we're going to make a to equal to 1. So pull out -5. So I have x squared plus 2x, and then the -9. So that means I got to find my new c, which is b divided by 2 squared, which is equal to 2 divided by 2 squared, which is equal to just plain old 1 squared, which is 1. So let me go ahead and add 1 to this side. What did I really do here? Did I really add 1 to this side? Well, let's take a look. Nope, I didn't really add 1. I actually subtracted 5 to this side. So if I subtract 5 to this side, that means I'll have to subtract 5 to this side, right? So this means -5. But I can't keep it over on the other side, so I have to add 5 and add 5 so that this will go away. Okay, so there we go. All right, so now we're ready. F of x is equal to -5. I can factor this perfectly, which is x plus 1 squared, and then whatever this comes out to be, which is -4. So this tells me my vertex. Actually, you know what? Let's do this. My vertex is -1, -4. My axis of symmetry is going to be -1. Oh, sorry. X equals -1. All right. So let's go ahead and find my y-intercept, which I know is x is equal to 0. So that means I have to find f of 0, which is going to be -5 times 0 squared minus 10 times 0 minus 9. So f of 0 is going to give me -9. Okay, so this gives me the point of my y-intercept. Let's put in red here, which will be 0, -9. Okay, so we have some key points here. We got the vertex, we have the axis of symmetry, and we have a y-intercept. Okay, so those are so far so good. However, I should probably also find, so let's go ahead and bring this right here, down here, because we already know that. So let's find our x-intercept, which is y is equal to 0, okay? So now we can either plug in this y equals 0 right in here for this, make this f of x 0 and then try to figure that out, or I could plug in here. Doesn't really matter. So let's go ahead and plug it into the top here. So I got 0 is equal to -5x squared minus 10x minus 9. So if that's the case, I can use the quadratic formula, which states that x is equal to -b plus or minus the square root of b squared. Actually, let me start plugging some of these things in. This is -b, so I got actually, let's make this blue. So I got -10, right? Plus or minus the square root of b squared, which is 100, minus 4 times a times, times c all over 2 times a. Okay, let me see here. I don't like what I see here, so let me see if I can do this and blow this up a little bit because I don't like squishing this -9 in here. There we go. All right, so that means I have x equals 10 plus or minus the square root of, what does that give me? 100 minus 4 times -5 times -9. I get the square root of -80 all over -10. Uh-oh. What does this tell me? What does that tell me? I should probably use, let's use red because it's urgent, right? Oh, it's urgent. I don't know why I just, so undo it. So that is gonna tell me, I don't even need to finish this, right? Because my discriminant already told me that there is no x intercepts. And that red might be hard to see, so maybe I do need to change it to something different. Like, would that green work? Okay, how about this green? Yeah, that'd be better. Okay, so let's do that. So this tells me that there is no x-intercept. Okay, so with that being said, awesome. So now I have done everything that this has told me to do. So let's go ahead and plot this and see what it looks like. Okay. All right, so here's my x-axis, here's my y. All right, so what do I have? I have my vertex, which is -1, -4. -1, -4 is right here. I have my axis of symmetry, which is right down the center of that, right? So let me make this all dotted. And then put some arrows on the ends, right? All right, so my y-intercept is 0, -9. So 4, 5, 6, 7, 8, 9. All right, and I have no x-intercepts. And I know it's a frowny face. So if I use my, like the last step says, right? Use symmetry to plot. So here is the axis of symmetry. That means if 1 over, that means 1 over, I have another point right here. So that means I should have a second point right here. All right. So that means my curve should look something like this. My curve should look something like this. My curve should look something like this. There we go. And what if I extended this out? Let's see. Well, you know what? No, I'm gonna leave it like this and then put some arrows right here so that it looks like that I meant to draw it that way. All right. So there we go. And in fact, let's go ahead and do this and this and this and actually change this to a different color like that so that it doesn't look like the line is crossing through it. All right. So that's how we would go ahead and actually do that. All right. So let's continue on and see what else is in store for us. Question is, can we find the equation of a quadratic function if we're given a vertex and another point? And the key point here, or the key word here, is that this word vertex, right? Ooh, it's going to give me an arrow apparently. So the word vertex, right? So with a quadratic function and vertex, that tells me I ought to use the quadratic form. I mean, the vertex form of the quadratic function, which is f of x is equal to a times x minus h squared plus k. All right, so let's go ahead and do that. Let's go ahead and plug in this vertex right in here, right? So great. So f of x is equal to a times x minus a negative 3 squared plus a negative 7. So what is that going to give me? Okay, not bad, not bad, not bad. So maybe what I should do is change this to blue so that I can do this point and change that to blue so you guys can see where the blue came from. And then maybe I should change this here to red. So now I can plug in this x and the y. So let's go ahead. So let's replace the y with 2 and the x with 0. So I should have 2 is equal to a times 0 plus 3 squared minus 7. Okay, let's take a look here. 3 plus 0 is 3, squared is 9. So that means we're going to have 2 is going to equal to 9a minus 7. So that means a is going to end up being 1. All right, so I had to rewrite this, right? I'm just going to replace this a with 1. So that means I have f of x is equal to 1 times x plus 3 squared minus 7. Now, is this 1 really necessary? No, it's not. It's not necessary whatsoever, right? So, therefore, this is my actual equation right here. Well, I hope that helps. All right, so let's go on to the next thing here. So, again, key point, vertex. That's why vertex form. Okay? What if we're given 3 points and we got to find the equation? All right? Now, if you notice right here, it says nothing about vertex whatsoever. We can't assume any of these are vertex. All right? So, since it's not telling me that, I'm going to tell you that you're going to have to use f of x is equal to ax squared plus bx plus c, right? We're going to have to use standard form because there's nothing that tells me about vertex, so I have no information about the vertex, so I'm going to have to stick with this. So what I'm going to do is I'm going to take that first point and I'm going to plug it into this and see what I get. When I plug it into it, I know my y value is 13, and that's going to equal to a times negative 2 squared plus b times negative 2 plus c. Okay, what does that give me? That gives me 13 is equal to 4a, because negative 2 squared is 4, minus 2b plus c. All right. Then let's take a look at the second point. Let's make it blue. So when I plug that in there, let's see, it says 13 is equal to a times 4 squared plus b times 4 plus c. What does that give me? That's going to give me 13 is equal to 4 squared is 16a plus 4b plus c. Okay. Then what about this last point? Oops, did not want to duplicate it. I would just want to change it to green. So that's going to give me negative 3 is equal to a times 0 squared plus b times 0 plus c. What does that tell me? Oh, that tells me that c is equal to negative 3. Ooh. Partly done already, right? I got the C. I just need the A and B, right? So that means I have plenty of places that I can put the C. I can put it in here, because then I know this part. I have C here, and I got C here. Let's plug it in there, all right? So if we were to do that, then I have 13 is equal to 4a minus 2b minus 3. And I have 13 is equal to 16a plus 4b minus 3 as well. Oops. Minus 3, right? Okie dokie. Great. So, what do I have now? So this is going to become, I got to get the 3 over to the other side, so I'm going to have 16 is equal to 4a minus 2b. And with the blue, same thing, 16 is going to equal to, I forgot the a over here, didn't I? So 16a plus 4b. Okay, so now I can do elimination or substitution. Let's do elimination, okay? So let me go ahead and take this right here. And what I'm going to do is, in case if I want to do double elimination, I could. But over here, I can see that these coefficients here, one is positive, one is negative. So why don't I go ahead and make this top one a negative 4b by multiplying it by 2. Okay, so if I multiply the top by 2, what do I get? I get 32 is equal to 8a minus 4b. And my denominator, or the blue is going to stay exactly as is. No change, right? Because I'm not multiplying it by anything. So if that's the case, when I add these two together, what do I get? Let's see. I get 48 is equal to 24a. So a is going to equal to 2. All right, so now I have a c and I have an a. Okay? Now, how should I go about finding the b? Any ideas? Yes, you can definitely take this a and plug it back into here, or you can take the a and c and plug it back into one of these original ones if you want to. Let's go ahead and do this since you know what? Let's plug it into this equation right here. Okay, so I'm going to take this a, I'm going to go ahead and plug it into this equation right here. Oh, the a is over here, so let's go ahead and plug it into that. Okay, so if that's the case, then I got 16 is equal to 16 times 2 plus 4b. Then I got 16 is equal to 32 plus 4b. So negative 16 is equal to 4b. So b must equal to negative 4. Okie dokie. So 2 into, 2 in for a, right? 2 times 16 will be 32. Subtract it over will be negative 16. Divided by 4 would be a negative 4. What if I plug in 2 into this one here? So 2 times a would be 8. Subtract that would be 8. Divided by negative 2 would be negative 4. Okay, so now that I have my a, b, and c's, now I can rewrite my function f of x is equal to a, 2, x squared, b, minus 4x minus 3. So that, ladies and gentlemen, would be my equation. Well, I hope that helps. If there's any questions, please let me know. See ya. Bye.